Now this illustration deals with outside secondary conductors tapped off of the secondary side of a transformer. Before we get too deep into this illustration, let's review the note at the very top of the illustration. And notice we have secondary conductors and we have 2-aught conductors, THW in copper, parallel 4 times per phase. So in the panel board, you can see that we just have 1 conductor per phase, but the note says no, there's 4 of them, and we just used 1 per phase to make it not as busy looking to you. But we do have 4 2-aughts parallel per phase, and we have a 600 amp 3-pole main that they're terminating to. And notice it's supplied by 13,800 volt with a 3-phase overcurrent device back maybe in a substation or from one building feeding this building from a main building. But the main thing, we have a main ahead of that primary, but we're tapping off of the secondary, and there's no requirement for length until you enter into the building from that secondary side. Now, this is customer owned. It's a 500 kVA transformer. Now, let's look at the application of 240.21 C4. Now, step 1, we're determining what the output of that secondary side of that transformer would be, which is 480 volt, 277 volt system. So we are basically then taking 480 times the square root of 3 into 500 kVA times 1,000 to derive a full load amps of 501,700. So we're having 501 amp, 0.7 amp, which would actually be, if you want to round up, that would come up to, I'm sorry, my eyes are failing me here a little bit. That's 600, I'm sorry. It would be 602 if you wanted to round it up. Or you could just stay at that value. Now notice we have a 600 amp overcurrent device in step 2 that's in the illustration. So we are protecting that transformer output in step 2. Now the solution is, from the secondary side of that transformer, we terminate in a 600 amp device with 4 2-aught conductors parallel per phase. A 2-aught conductor, which if we should reference table 310.16, they have an ampacity of 175 amp from the 75-degree column. 4 of them in parallel is 700 amp. So our overcurrent device is protecting the conductors, the output of the transformer, and the panel board at 600 amp. Now, the note says the authority having jurisdiction may allow 4 1-aughts, and 4 1-aughts would give you 600 amps exactly. So again, it's always wise to check with the authority having jurisdiction or the plan checker of a particular state, county, or city, and see exactly what are they going to require when you have an installation of an outside transformer, making an outside transformer secondary conductor tap in accordance with NEC 240.21 C as in car 4.